Now let's do number 4. So number 4 it's a problem that's just like that airplane question that I did in class, alright? So a man is walking due north on a straight road. Okay, and I put it in the desert to emphasize its straightness, but it's just a straight road that goes in a single direction. And then what happens to him? He's going at a rate of 3 feet per second, and at time t equals 0 he passes a radio tower, and it's 700 feet over to the left. So here is 700 feet over to the east. Alright, and so this is at t equals 0. And now it says d is the distance the man has walked in feet since time t equals 0. So we're going to make a triangle here. This side is going to be d. S is the distance between the man and the radio tower. So just to make things a little more clear, let me say that this is the man, and here's the tower. And so we're interested in the distance between those two things, which is s. And the goal here is to give s as a function of t. Alright, so we're going to do that just like we did in class. And so what is the trick? The trick is first to write d as a function of time. And we can do that because we know the rate. The rate is 3 feet per second. Okay, so since the rate he's walking north is 3 feet per second, we know that d as a function of time is just 3 times t. Okay, so this is how many feet he's gone t seconds after t equals 0. Alright, and so what is s? Let's just first give s as a function of d using the Pythagorean theorem, just like in class. So this is 700 squared plus d squared. And now to get s in terms of t, we just compose. Let me emphasize that we're composing here. Compose s and d, and then you get s as a function of time, and it becomes the square root of 700 squared plus 3t squared. Okay, and make sure that the square hits your 3. See, the way that I've written things, this square is being applied to this whole quantity, right? And that's right. You don't want to write like 3t squared. The 3 needs to be squared also, because that's part of what d is. Okay, and so we've answered a here. The answer to a is the square root of 700 squared plus, we could call it 9t squared. It's the same thing. And let's just call this s as a function of t. Alright, so that's part A. Now this problem kind of changes into a question about average rate of change. I'm just sneaking this in here. So remember what average rate of change is. So the average rate of change of a function between a and b is s of b minus s of a divided by b minus a, where b is the bigger number. The average rate of change of s in terms of t between t equals 0 and t equals 1, that is just going to be 1 minus 0 on the bottom is 1, so I don't even really need to write it. And on top I've just got s of 1 minus s of 0. Okay, so let me write that out in terms of the function. So this is going to be, this is actually the answer to b here. This is going to be, what happens when we plug in 1, we've got the square root of 700 squared plus 9. Excuse me. And what are we taking away? We're taking away what we get when we plug in 0. And when we plug in 0, we get the square root of 700 squared plus 0, which is just 700. And maybe I'll come back in a second and write this in a nicer form. But for now, this is the answer to B. And let's go ahead and do C. Alright, so what's the difference between B and C? Just bigger numbers. So it's the average rate of change between S and when A is 1000 and B is 1001. So we do it again. So it's just S of B minus S of A divided by B minus A. So just like last time, the difference between B and A is 1. So we get 1 down here. This is very easy. And on top I write S of 1001 minus S of 1000 and let me just plug that stuff into the function. So I end up getting the square root of 700 squared plus 9 times 1001 squared. And I'm taking away the square root of 700 squared plus 9 times 1000 squared. Okay. Alright, and so we've got the answers here. They're not in nice numerical form. Why did I ask this question? We're kind of done with it. So, if you put that on your paper, that's full credit. And what was I trying to do? Okay, so I was thinking, as the man walks forward, this triangle is going to start to look skinnier and skinnier, right? So if we look at the average rate of change when he's far away, so during 1 second he's going to be moving something more like 3 feet away from the tower when the triangle gets skinny, right? But when he's close to the tower, like in this picture over here, if he moves 3 feet forward in 1 second, then his speed moving away from the tower is going to be a lot less than the rate at which he's actually walking. But the longer he walks, the more it's like he's walking kind of directly away from the tower. You see what I mean? So the average rate of change, the answer to part C, should be a number that's much closer to 3 than the answer to part B. And so it might be interesting to see that. So let's just go ahead and put these numbers into the calculator. So the first one is this one, the square root of 700 squared plus 9 minus 700. So let's do that. So we want the square root of 700 squared minus 9, and then what are we doing? We're taking away, what am I even writing here? 700 squared plus 9, and then we're taking away 700. And what does that turn out to be? That turns out to be this number. So 0.006, let's just call it that. So 0.006. So that means that he's walking 0.006. So he's at the very beginning, he's hardly walking away from the tower at all. See? Look, imagine that he was like right here. Then it would be like he's not really moving very far away from the tower, right? It's almost like he's moving in a semicircle around. But later on, after 1,000 seconds, the picture is going to be much more like this, and so we should expect it to be closer to 3. So let's see what happens. Alright, so let's do this. Oops, I wrote this in the wrong place. So 0.006 is what B turns out to be. This is 0.006. And now let's do the one for C. So let's see if I can remember those numbers. So I've got the square root of 9 times 1001 squared. And now what are we doing? We're taking away, squared. Let me copy this. We're taking away the same thing, but we just changed this to 1000. See, it's almost 3. It's 2.92. So it's 2.92. Oops. So 2.92. The rate of change is feet per second, right? So he's walking away. So later on, after 1,000 seconds, it's more like this skinny triangle. It's almost like he's walking directly away from the tower, whereas early on he's moving kind of parallel to the tower almost to this very first second. And that's it. That's it for number 4.